Hey everyone, welcome to Coding Vibes. This is the second part of our interface segregation principle video. In this video, we are going to code the example that we took in the last video, and we'll look into another example to understand interface segregation principle in detail. So let's start with looking at the code for the example that we took in the last video. Here we have payment processor has a process payment method, right? And then we have one implementation of it, which is PayPal payment processor. Over here, we will be having code related to PayPal. As we discussed in our last video, if you want to handle refunds as well, one way could be we can have another method over here. Let's say process refund. So it looks good, but there were few problems when we add this particular method in payment processor, and it starts violating interface segregation principle. So you can always go back to the previous video and where we discussed what is the problem adding this particular method in this interface, right? For now, I have created another interface which is refund processor, and it has a process refund method, right? Now I have a refund service, and what it does is it implements refund processor. We can write logic to process a refund over here. If we have multiple ways of processing a refund, we can always have multiple implementing the refund processor. Payment processor is highly cohesive. It only does a single work of processing payment. That is what we discussed in our previous video, where we were talking about the definition of interface segregation principle. This is about the example that we took in last video. Let's go over another example and try to understand ISP in little more detail. So assume that you want to build something like a media player. So when I'm saying media player can play a audio, it can play a video, it can play a image, right? So that's when we have this particular interface media player, and it has three methods. One is audio player, another is video player, and the last one is image player, right? Now let's go over one of the implementation of media player. Let's say we want to implement a simple audio player. So this simple audio player, what it does is it plays a audio, right? So over here, simple audio player implements media player, right? Now given media player has these three methods, now simple audio player will have to implement all these methods. I think by looking at the code, you already would have identified that there is a problem with this code. In context of simple audio player, there won't be any implementation to these methods, right? So it's like the media player is so generic that it is doing three things. It can play a audio, it can play a video, it can play a image. Now problem is whenever we are implementing, let's say the simple audio player, we will have keep these two methods empty, and there is a chance that whoever is using simple audio player, they can actually make a call to video player, and that would be a problem, right? So it would be a unexpected behavior in the application that we are building. So that's when ISP comes into the picture. So this media player can probably be divided into three narrow focused interfaces. So the first could be audio player. It will have a method, let's say play audio. The next one could be a video player. Let's say it has a method play video. The last one could be a image player. It could have a method called, let's say, play image. This image player is nothing but let's say if you open your photos app, one way is you can left or right swipe the photo, you will keep on seeing the next or previous image, right? That is one way of playing images, right? One could be the up or down scroll, right? So those could be implementation to image player. So let's try to create implementation to these interfaces. First, try to create a simple audio player, and then let it implement audio player. So we will have to implement play audio method from audio player interface, right? And for now I'm just saying play simple audio, right? So if you see now, our simple audio player is very focused, right? It has a simple method to play audio, and we can have our logic to play a simple audio player. Similarly, we can implement, let's say, a background audio player. So you might have seen the music players that we use nowadays. You can actually minimize the app and the music keeps on playing. So let's say that is something, we say it as background audio player, which again implements audio player. The play audio method over here would be having logic to play music in background. Let's create one more implementation to video player, maybe full screen video player. So it's nothing but if you play a video in the application that we are creating, we can expand the video in full screen. So that is what this implementation would do. So what it can do is it can implement our video player interface. Then the play video part would be having logic to play the video in full screen. Now let's create a simple implementation for our image player as well. Let's say scroll up and down image player. We can have logic inside play image that would have a feature where user can scroll up or down to play the images. If you see, earlier we had this media player which was not very much focused. It was very generic that it could play a audio player, video player and image player. And the problem with that is implementation to create a audio player, a type of audio player would have these two methods as well. So with that, there is a possibility that there is an implementation for audio player and you may call from that audio player to play a video, which would be a unexpected behavior. So that's when we decided to have separate interfaces, narrow focused interfaces, like audio player being only used for implementing different type of audio players, similarly video player and image player. So this is the example that I wanted to discuss. I hope with the examples that we discussed today, ISP would be really very clear. Up next, we are going to look at the benefits of ISP. So I've listed down the benefits of ISP. Let's start with the one that I could not add to this list, but we talked about it for the video, which is about if we adhere to ISP, the system would be highly cohesive. So cohesive is something I have not listed over here, but I think we have discussed enough about it. The another one is reduced coupling. So the interfaces adhering to ISP will have fewer dependency, right? And then it will lead to reduced coupling. And when we have lower coupling, it means that the changes made in one part of the application is less likely to have ripple or side effect into unrelated part of the application. So this is very important. The other thing is modularity. So whenever we adhere to ISP, the interfaces would be very narrow focused, hence the code would be very modular, right? And the other advantage is better encapsulation. So whenever we follow ISP, we make sure that only necessary methods are exposed to the client, which helps to hide the implementation detail and prevent the clients from depending on unnecessary or irrelevant methods, right? So better encapsulation is another very important advantage of ISP. There are other points as well, like maintainability, extensibility, reusability and scalability, which I have listed over here. If you are following the video from start of the solid principle series, you may be able to easily understand why maintainability is an advantage to ISP, right? It's as simple as, given everything is very narrow focused, right? So it would be really very easy to maintain that code base. And extensibility in the similar line, given the interfaces are very narrow focused, if you want to add any new feature, you can extend the narrow focus interfaces or create a new one and implement a new feature. So extensibility becomes really easy. So these are the major advantages of ISP, and this would be the end of this video. Thanks for watching.